Bismillahirrahmanirrahim. Assalamu alaikum. Myself Shehbaz. I am a student of BS Physics, 7th semester, University of Central Punjab, Lahore. Topic is Fermi gas model. The Fermi gas model defines properties of a system of non-interacting fermions in an infinite square well. So, in nuclei model assume that proton and neutron are independent fermions filling two separate potential wells, suitable for predicting the properties of highly excited nuclei. We'll explain Fermi gas model through an examples. So we will discuss now basic concept of Fermi gas model. The theoretical concept of Fermi gas model may be applied for the system of weakly interacting particles being fermions. Direct statistics leading Pauli's exclusion principle. Now here we will discuss through two examples like fermions and bosons. Fermions are that protons, neutrons and electrons are exist in fermions. These are also explain the Pauli's exclusion principle half integer spin. Bosons are not obeying the Pauli's exclusion principle. The gas particles are at the same state. Instead of fermions, they are at the same state of gas molecules. In figure, we will discuss bosons and fermions. In this figure, bosons are at the same state. The gas molecule are in ground states. Instead of fermions, the molecules are at different states like first state, second excited state, and third excited states. In the diagram, we will have explained the fermions and bosons. We will discuss bosons and fermions through another diagram. In this diagram, we can say that first two atoms of gas molecules occupy in ground state. The next two atoms of gas molecules are exist in second excited state. Next two atoms are in third excited state, and so on. In minimum energy of configuration of consist of large number of particles fill up energy levels one at zero temperature. Even at given temperature, the collect these particles will be non-zero. At ground states configuration where all the particles having minimum energy levels, each particle have a different energy to each other. Now here we have two particles. If those two particles have collides to each other, then assume that these particles have different energy levels. They are moving inside the nuclei and come close to each other. Through an diagram we have explained this. The result is that they are just exchange their energy levels. If we have explained this through classically, when two or more neutrons come close to each other, through classically we can say that they are exchange their velocities. In quantum mechanics, when two or more electrons or neutrons close to each other, they are not occupying the same state and moving around the nucleus and have different energy levels. So we can say that they are just exchange their energies. In classical mechanics, they have just exchanged their velocities, and in quantum mechanics, they have exchanged their energies. Now, how to calculate the Fermi energy? From the diagram, we can explain or calculate the Fermi energy from top state of energy subtract to the lower ground state energy is called Fermi energy. Like we have said that in this diagram, the lower ground state energy electrons and top energy electrons, the main difference is called Fermi model. Fermi energy, we can also say that this is a Fermi energy. The neutron and proton energy, for a typical, we assume that a structure have three-dimensional square well potential. The formula of Fermi energy neutron is that EF is equal to h cut ka square, or F ka square over 2m is equal to h cut ka square over 2m into 3 pi ka square rho whole power 2 over 3. This is the energy of n number of particles. We calculate the Fermi energy of neutron and protons, then we have proved that the main difference in nature. each other. Neutron Fermi energy is equal to 43 mega electron volt and proton Fermi energy is equal to 33 mega electron volt. This is the main difference in neutron and proton. So we have proved the Fermi gas model. So this is the end of my presentation. Thank you so much.